This video is over topic 45, numbers 5 through 8, using not and or with probabilities. So the rules for counting with not and or apply also to probabilities with not and or. Now, generally, it's probably easier to just do the counting part of it. So you know how to find the number in A and B, you find that and divide by the number in S. You know how to find the number in A or B, you find that and divide by number in S. So number 5, 32 trials on the docket at a court. 5 are homicides, 12 drug, 6 assault, 9 property, and we are looking at one of those 32 trials being randomly chosen to assign to a juror. So what's the probability that a given juror will not get a homicide case? Not get a homicide case. So the number that are not homicide, well, one way to do that is to go ahead and add up the 12 drug plus the 6 assault plus the 9 property and get that's 20, no, get 27 not homicide. Or you could also do that's the N of S minus the number that are homicide. So 32 minus 5. So the number, not homicide, are 27. Then the probability, not homicide, is 27 out of 32. Okay, next up, a 2-pound bag of Hershey's miniatures contains 33 milk chocolate, 27 crackle, 26 Mr. Goodbar, and 19 special dark. If you're choosing at random out of that bag, the probabilities, these are all going to need to use N of S. So we need to know N of S. That's going to be adding those all up. 33 plus 27 plus 26 plus 19 is 105. So probability of selecting a Mr. Goodbar, there are 26 Goodbar out of the 105 total. So that's the probability, but now we are doing decimal, so round to the nearest thousandth. So I'll go ahead and do that division. And that comes out 0.248. Probability of selecting a crackle or special dark. So you grab a candy bar. If it's crackle, you're good. If it's special dark, you're good. So that's going to be, there's no overlap here. So just the 27 crackles plus the 19 special dark, looking at 46 total that are going to make this true out of the 105. So 46 divided by 105, 0.438. Then not selecting a milk chocolate bar, again, you could add up the 27 plus 26 plus 19 and get 72 non-milk chocolate. Or you could do 105 minus the 33 milk chocolate to get the 72 not milk chocolate. Either way, 72 divided by 105. 0.686. Number 7, now we have items described by two characteristics. So small stars, big stars, small rockets, big rockets. Those could be on a table of values, but here they're just listed. but we're choosing, um, looking for the probability of choosing something that's small or is a star. So the 9 small stars are included because they're small. They're stars. Doesn't matter that they're both. As soon as they're either one of those, they're included. The 7 big stars are stars, so they're included. The 8 small rockets are small, so they're included. The 5 big rockets, they're not small. They're not stars. They're not included. Now we're going to need the total N of S is 9 plus 7 plus 8 plus 5, which is 29. Then for the small or star, you could do 9 plus 7 plus 8 to get 24. Or you could do 29 minus the 5 um, that are not small or star. And still get 24. So 24 out of 29 are not, or 24 out of 29 are of those stickers could be described as small or a star. And so 24 divided by 29, round to the nearest hundredth, is 0.83. Then number 8, a vase of roses has 4 buds and 6 open flowers. So that means there are 10 altogether in the vase. Half the open flowers are red and half are white. So we have the 4 buds, the 6 open, half of the open. That means that's made up of 3 red and 3 white. Then 1 rose is selected at random. What's the probability it is an open white rose? So there are 3 that are open white out of the 10, depending if you're asked for decimal or fraction, 3/10 or 0.3.